If you look at every other industry, construction is going almost backwards in productivity. We have not done a great job of pushing speed and efficiency in our world.
Welcome to the Passive House Podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House Podcast. Welcome back to the Passive House Podcast. I'm Matthew Cutler, coming to you from Auckland in New Zealand.
And I'm Zack Semke, coming to you from Seattle, Washington.
Good to see you again, Zack. Pretty exciting episode coming up this week.
Yes, indeed. As you'll hear from my enthusiastic interview, I am a huge fan of this project and of the work that Nick and his collaborators are up to in Massachusetts.
Yeah, we are heading to Massachusetts this week for some pretty exciting stuff. So we should jump into that sooner rather than later because there's a lot in this interview. There's a lot to cover and some really great stuff in there. But before we do that, we've got a few people to thank.
We do indeed. So a big thank you to River Architects, who is our accelerator partner of the week and is making everything we do here at Passive House Accelerator possible, including this Passive House podcast. Thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. And thanks to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwell North America, and Zola Windows. And thanks to our champion sponsors, Bewizo, Cascadia Windows and Doors, European Architectural Supply, Icon Windows and Doors, Intelligent Membranes, LG Air Conditioning Technologies, Proseco, and Source 2050.
All right, Zack, before we jump in, tell us a little bit about where you came across Nick.
Yeah, absolutely. So I had a chance to speak at the Passive House Massachusetts Passive House Symposium back in early December in Boston. And as listeners probably know, there's a real explosion of Passive House adoption happening in Massachusetts and in Boston in particular. And I had the chance to visit the work trailer for the Bunker Hill Housing Redevelopment project, and then also tour one of the buildings, the first building that's been built there. And we're going to talk a lot about this in the interview, so I won't describe the project, but Nick walked through his approach and the team's approach, lots of great project partners, including RDH Building Sciences. And I was blown away. As you'll hear, it's just a really exciting approach to construction in general. And this combination of CLT and prefab panels and Passive House and driving down the carbon emissions from this building, as well as the cost, driving up the performance. It's really, really interesting and replicable. So it was fun to talk about.
One term, before we dive in, one term that did jump out was the stretch code. Just remind people why Massachusetts is particularly special.
Yeah, that's right. So Massachusetts has this specialized opt-in stretch code, or I think is the term. Essentially, it mandates Passive House or Passive House levels of thermal energy. It's one or the other for all residential buildings 12,000 square feet or larger. I think I've got that right. I think I said residential, and maybe it's all buildings 12,000 square feet or larger.
Essentially, as I understand it, it's one of the first places in the US to have a code that is pretty close to Passive House.
That's right, and it is Passive House. It is
all Passive House.
Yeah, right, exactly. And in fact, the thermal energy demand route can, I think, be even harder than Passive House. So it's like it's the real deal. And the opt-in part is that local jurisdictions, cities, get to decide if they're going to adopt this code as their code. And cities that comprise the majority of the population of Massachusetts have indeed done that. And so that's why,
This is your conversation with Nick Nigro from Leggat, McCall.
A certified Passive House building. So that's either FIAS or PHI. In Massachusetts alone, there's over 30 million square feet in the pipeline right now. So that one
Wow.
state is going to create this really steep hockey stick of
Mm.
adoption of which is already it's we're already seeing exponential growth in passive house, albeit from small numbers. Well, those small numbers are getting a lot bigger very soon,
Yeah.
and Boston's in the center of it all.
Yeah. And the other context is that there's an affordability crisis and just a supply crisis as well, big, massive demand for housing. So that's some good background. Well, let's dive in.
Well, I am very happy to have Nick Nigro here on the Passive House podcast. Nick, welcome.
Yeah, thank you very much, Zach. I'm very excited to chat.
Yeah. I am really excited about this interview. I was just so inspired by the work that you're doing in Boston. When I visited, now it's almost been 3 months ago, back in December of 2025, and got a chance to hear from you directly about the work at Bunker Hill Housing Redevelopment. So really, yeah, it's so cool. So let's start though with just hearing your story a little bit and how you got involved in this and a little bit of your backstory, and then we'll dive into the work that you're doing today.
Sure, happy to. I guess we can start all the way back at the beginning. I guess I come from a family of builders in some respect. My grandfather was an architect. My father was a contractor. I grew up, with a hammer in my hand. And, I went to school. I didn't know if I wanted to be an architect or an engineer. And I found this wonderful program at Penn State that's called architectural engineering, which was, directly, working in building sciences, rather than other typical engineering disciplines, which really set me up for, an excellent foundation, I would say, coming out into the large construction realm. So I went to school, stayed for my master's, and then I got out in a pretty unfortunate time, I guess, in the economy, which was in 2009.
I
There
remember
wasn't,
those days.
yes, there wasn't much going on, but luckily I got a job, starting as a project engineer with Suffolk Construction,
Hmm.
and
Yeah.
worked on a new kind of project right out of the ground for Suffolk University, which was building a new dorm building that I then rode into a 12-year career with Suffolk, and then I transitioned from Suffolk over to Leggat McCall about 5 years ago, and then really started to focus on Bunker Hill was that main transition. So I've been working on Bunker Hill now for almost 6 years, on the other side of the tracks, and then also with Leggat McCall.
Yeah, awesome. Yeah, that's quite the pedigree. And Suffolk Construction was just built the massive high-rise Boston or high-rise passive house project in Boston, right? The Millennium
Correct.
Tower.
Yes.
Yeah.
Yes.
So that's awesome. And so Bunker Hill, I mean, people who aren't familiar with the Bunker Hill housing redevelopment, this is Boston. It is the Bunker Hill. If you've been watching the Ken
Literally.
Burns
Yes.
Revolutionary, right,
Yep.
you'll there's a really important battle that happened there, and there's been housing there for a very long time. Could you just give us the overview of what Bunker Hill housing redevelopment is about?
Sure. So after the war, basically there was a public housing block that was built right on the backside of Bunker Hill. So this is in Charlestown, Massachusetts, which is a part of Boston proper. Those, buildings consisted of 40, I believe 42 existing buildings are there that were built, in, I would say an incredible speed. And, if you think about the gusto of everybody coming back from the war and just kind of getting at it, they really hammered these out, but they were, very
And this
old.
is World War II, not the
Yeah, World
Revolutionary
War
War.
II. Yes, correct. Yes, that is exactly right. So they hammered these 42 buildings out, a long time ago, and this was, again, set up as public housing to be maintained and built in a way to last. In other words, these were very robust existing
Mm,
buildings. But unfortunately, just because of the environment, and in certain federal funding limitations, the condition of those buildings, deteriorated over time. So it was deemed, I believe, back in the mid 2000s that they it needed to be redeveloped just because of the condition of the existing buildings and some of the conditions that obviously the folks that were living in there were becoming untenable. So that RFP was produced by the city, I believe, back in 2016, to go out and find developers to come in and propose different ways to redevelop this into more of a vibrant mixed income community. So we got involved. Like McCall got involved in around 2000, I believe, 18, when the first developer really couldn't come up with a good, combination of both building sizes, and then financially to be able to support it. So, we kind of came in as the lead developer, and then I started to, become involved with this project around the same time while I was still on the Suffolk side of the tracks. But the intent again, was to take these dilapidated old buildings and then turn them into new, extremely high performing buildings that would, be a beacon to the future of what folks both on the affordable side and the market rate side should expect to be living in this new world of technology and advancements that we have. So those 42 buildings will be demolished in phases over time. So we relocate folks for a period of time, demolish blocks of those buildings. So for the first 2 buildings, we demolished 6 of those buildings to make way for 2 new buildings. And over time, those 42 buildings house 1,100 existing units. That'll get converted into 2,699 new units, which will replace the 1,100, and then the balance will be new market rate units.
Mm-hmm. Mm-hmm. And so is that roughly 7,000 occupants? Is that right overall?
Well, if you convert the units into people, I mean, I don't know how you actually, what that rough math would be.
Why do I? Yeah. No. Okay. Cool. Yeah, it'd be less than 7,000 probably. But so yeah, a big project. So 15 buildings, and correct. And you are currently working on the second building.
Yes. So we completed the first building, which was 102 units. It was 6 stories. That was back last year. We basically occupied that building, which was a fully affordable building, was the first one. So all of the 102 units were replacement units for the existing folks that were there. That building is now, in operations for over a year now, and has been, running very well. We just are about to get out of the ground with building number 2. This is a little bit larger of a building. It's 266 units at 9 stories. And we're going to be, this is kind of the first mixed income building that we'll be putting together. So it'll be 22% affordable with 78% on the market rate side.
Got it.
Which we hope to, really push the kind of, financial kumbaya, where everything will, eventually over time, help subsidize each other and make it work as a really vibrant, mixed income community.
Yeah, awesome. And I'm eager to dive into some of the details here. Before I do, another kind of piece of the landscape that you're working with are the code changes that have been going on in Boston. So maybe could you talk a little bit about that and how that has shaped your planning?
Sure. So, let me step back a minute and say, when I got involved on the Suffolk side, the original charge from Leggat McCall was really to put together, something that was going to cost, 25% less and build it 50% faster than anything that we've typically done. And really what it comes down to is, if you look at every other industry, construction is going almost backwards in productivity. We have not done a great job of pushing speed and efficiency in our world. And that is, how I originally took this challenge on is, what is a kit of parts that we can build or, come to the table with that we can really iterate on over time, right? So these 15 buildings, our zoning envelope basically gives us up to 10 stories with a max to build. When if you think about, what you can do in traditional stick construction, you're really constrained to, 7-story, maybe 8 max if you're pushing some really low floor to floor heights. But it's really that no man's land of, call it 8 to 12 to 14 stories that we really wanted to focus on with a system that you can build in that realm for just as efficient cost as you would build, at a level that was lower than that out of stick. So before we got to kind of all the new, fancy CLT and all the awesome other components that we put together, we spent a lot of time looking at just the structural systems, right, of how you might put these together so that you could do it in a much more efficient manner. So we spent, I would say a year with a structural engineer and myself on the Suffolk side, just iterating through different, options of what we can do, even back to good old fashioned like block and plank. And how do you push these, different ones to push, the speed as fast as you can? That is not just to get heads in beds faster. It's also, a part of the financial equation, right? The less carry cost that you have on the backside of your pro forma is real dollars. You know what I mean? If you're saving 6 months in your schedule and you're not paying interest for those 6 months, it's hugely impactful. And so that was a big charge, again, to drive down the costs in order to push this forward. So, we spent, again, a good amount of time thinking about that. And then afterwards, brought in an architect to try to put it all together add the beauty to it and add the system. But the charge of creating that kit of parts was hugely important for us, from the jump, again, to drive that efficiency of construction. And I would say, on our first building, and we'll call it our beta test, which was building M, the 102 unit I just discussed, we put that together in 16 months, which, in general is pretty damn fast.
Yeah.
We learned a ton on that building, right? So it was one of those situations where you don't know what you don't know. And then you take all those lessons learned, which were 5 pages long, and then you bake them into the design of the second building, using the same kit of parts, but then, you really start to reap the benefits of it. And what I mean by that is, we're building, 9 stories, 266 units, so almost 2.5 times the size of the building in just about 18 months, right? So you can see that hockey stick learning curve there, really understanding durations of how everything goes together, and then, improving on certain details to make the work go faster. And that's that much more efficient in the field.
Yeah. And the passive house level of performance, was that something that was like, when did that become part of the conversation? And did the specialized, that I struggle with the jargon, the code jargon in Massachusetts, the specialized opt-in stretch code, or
Yes.
I probably have that wrong, but
No,
but
that is exactly right. It is the
yeah,
stretch code, and it was not, I
yeah,
would say, expressly driven by the stretch code. I'll go back to kind of our co-president of our company. One of the
yeah.
other things other than speed was, he wanted to heat it with a candle. It was how he called it, right?
Nice. Yeah.
So again, if you think about your financial equation, a lot of these units are affordable units where you pay, the utilities of the occupants. The less money that you're spending on energy and utility costs, helps that equation and that pro forma work that much better. So passive house,
Yep.
and this is a very important point, right? We adopted passive house as a standard, as we went to the city with our proposal, meaning this was a day one
Mm.
commitment that we made to
Mm-hmm.
the city of
Mm-hmm.
Boston, that this is how we were going to do it, not just because it's right for the environment, but because it's something that, we have the ability, we have the resources, and we have the know-how to be able to push this. And we thought it was something that it was, really beneficial to everybody, something that's really a win-win-win. And we stuck by it. And I would say that people, certainly I would say, have a little bit of trepidation when it comes down to building, in passive house because of the perceived costs that come along with that. But if you commit to it early and you design to it from the beginning, you can absolutely accomplish it, without a ton of premium. And I would say that we saw very little premium as a result of us adopting it so early and just baking that into the design as we rolled.
Right. And I know, and I think we'll get to this, but I know that the learnings from building one are being applied to building two, and there's some expectation of some significant cost decline. So, which is exciting. So you had touched on so much great stuff. One is the kind of, you alluded to the sort of lack of progress or innovation maybe in the industry. There's that famous McKinsey report that kind of outlined that for our industry. You also referred to this project as being a beacon to the future, and you talked about learning and lessons learned in this and applying those from one to the next. And that this is part of what is so exciting to me about the work that you're doing. I've been really interested in the parallels between the clean energy, what lessons we can take from the clean energy transition and apply to buildings. And this is something I've been kind of intrigued by for 11 years. And the idea that passive house, and as we'll get to very soon, the other innovations around CLT and structure and all of it, the idea that you can bring information technology to the process of modeling and designing buildings and understanding of building physics, and then this power of learning by doing, you can combine those to drive down cost and increase performance and make a better building. That's where the parallel is, I think, with clean energy. And there, of course, are important differences. Clean energy, we're stamping out millions of solar panels and over and over and over and over. We don't have the luxury of doing that in buildings. However, you have these 15 buildings that you get to work on over time and be literally applying the lessons to the next project in this really rigorous way that I think that you've set up. And that's what, I really admire how you've kind of set up that kind of rubric and way of practicing. So where am I going with this? So like that, you also mentioned hockey stick. There are all these great parallels that are being realized, I think, in the work that you're doing, and so let's get into the details of that so that listeners can understand it, because you are innovating with the panelization process with the CLT. The CLT is reducing the need for structure, which is less material, less cost. That's another parallel with clean energy. That as this innovation happens, we can use less material, which drives down cost. So that's a big, long-winded preamble to what is the kit of parts that you're applying to building one, so that people can understand that. How is that being morphed for building two? Let's start there.
Sure. And I'll step back 1 second too and kind of start with just the model side in general, right? So, we work in a world where, yes, you have unlimited computing power to be able to model things in a virtual realm, right? Try to understand theoretically what you're trying to put together, both on energy usage, inputs and outputs, as well as how those physical parts and pieces are going to actually come together, right? It is very hard. Maybe that's why our industry has been so difficult in terms of progressing with productivity and efficiency, because going from that digital realm to a physical realm and dealing with tolerances, that aren't super tight in the construction realm is a really big challenge, right? So, the first thing, one of the first things that we did was get into our WWII modeling, right, for Passive House very, very early. So you get your mass of your building and you start to understand what are the constraints that you're dealing with when it comes to your glazing ratio, when it comes to, how much exterior wall area you have. You try to set those boundaries for yourself very early, and then build a kit of parts around those to make sure that you're hitting them and not going backwards and redesigning in order to hit those metrics, right? So if you think about, your exterior wall and how you can optimize on the assembly of that exterior wall, you need to understand the theoretical inputs, but then you also need to get into a realm where you need to build it, test it, and then, actually understand that it works. That is a strenuous leap that we don't, I would say, push hard enough in this realm. And that's a lot of, really a lot of that is driven by risk. When you have a one-off project, capital doesn't have a huge appetite for, extreme innovation. They are looking for a return, not to spend X millions of dollars trying to innovate yourself into a realm where you're going to drive productivity and everything else beyond that, right? It's a pretty old school industry when it comes down to money and how buildings are developed. The scale of Charlestown with our 15 buildings is kind of what allowed us to escape that, that vortex a little bit, by convincing folks that if we can learn on the first one, we will drive that over time by, just like you mentioned, iterating on that kit of parts and getting better and more efficient and, more cost effective, and also, better with our Passive House practices. Before I get into the kit of parts, I'll just mention, like, our first wall performance mockup, right, to try to get that thing from the theoretical model realm into the physical world and then test it with a jet engine blowing water at it. It took 4 times for us to figure out how to get that thing done in that testing chamber, before we figured it out. The second building, we nailed it on the first try, right?
Right.
You know what I mean? So
Yeah.
you can just see how you learn from one to the next on just the details that it takes and how the pieces go together. So what are those pieces? Yeah, let's hit on those pieces real quick. So, there's kind of 3 main, technologies that we've really deployed on these buildings. The first of which is a precast core system. So if you think about, building a low-rise building, that's typically, your stair and your elevator core might be done out of CMU with traditional masons, right? That'll put staging up around it and stack those blocks up, right? The cost of that is certainly going to be much cheaper than precast, but the time that is associated with putting that together is much greater, right? That precast core might take 4 to 6 weeks to put up. We stacked up our cores in our first building in 1 week each, right? And not only did those cores, provide the shafts for the stairs and the elevators, they also had stairs. We dropped in prefabricated metal stairs into those cores and then capped them, which then gave us the ability to have vertical access up into the building as we walked, as we then erected the building around it. Now, not only did it have stairs and, the speed to it, but the other magic of the precast is that it takes the entire lateral load of the building. So we do not have any specialized shear walls or framing, elsewhere in the building, because those cores take all that load. So if you think about the cost, which is probably 3x, compared to a typical CMU, core, that precast core is now doing 3x of duties, right? That
Right.
you would have got, that you would have got
Yeah.
out of it. So if you think about, another downfall that we have and why I don't think we've advanced very well is that, we don't do a good job of holistically
Yeah.
analyzing our
Yeah.
building equation, right?
Hmm.
A developer sees the cost of a CMU and a precast, they look at it and they're like, no way, right? That's never going to work. But it's all about simplification. And you alluded to this earlier, right? It's all the stuff that you're not doing. It's all the money that you're not spending on temporary conditions. It's taking, 10,000 pieces and reducing that to 2,000 pieces,
Right.
right? And
Right.
making that connection of those pieces way simpler. So that's our goal, is to keep, addition by subtraction, if you want to make it super
Hmm.
simple, right? Is making
Hmm.
it simpler and simpler. And anybody knows that's in the design realm, it's extremely difficult to distill something, into a simple form that works really well, and
Yeah.
then it's also repeatable, right? So that's been the challenge. So you have your precast core, which is the first thing we do. Then, we create, load bearing prefabricated exterior walls, and I emphasize load bearing because it is not a typical way that you would frame, a high rise building. But again, this is a method by which we are getting double, triple duty out of these walls. You're going to have an exterior wall anyways, right? If you're a non-load bearing setting, you're just going to hang it off the side of the building, and your studs might be a little bit lesser of a gauge and thickness, but you're still going to have a frost wall, that you're going to sit that on the foundation. But now, instead of having just a frost wall in a non-load bearing situation, you now have demising walls that are all load bearing, and they all have structure under them. They all have foundations. That's more digging. That's more concrete. That's more time coming out of the ground, right? So our philosophy was, we're going to make it load bearing, right? You're going to use that frost wall. You're going to make the studs a little bit thicker. And then you're going to span your CLT from one side of the building, right, over to the other side in a single panel, where you're going to bear on both exterior walls and then your two corridor walls. And again, if you think about how many parts and pieces go into a floor system, that CLT panel is a single panel that's 8 feet wide by 62 feet long, that you're dropping like planks, like Legos, you know what I mean, on top of those load bearing walls. We were doing 7,000 square feet a day by the time the guys got good at it, on the last building. It was incredibly efficient to be able to drop that CLT in. And not only does that, the CLT give you excellent productivity, it's a huge check in the sustainability, side of the world. And in terms of aesthetic, now your unit, has a beautiful exposed wood ceiling in it rather than walking into a white box. So again, you're trying to combine, and get as much value out of each one of these parts and pieces as possible. And I'll just go back to the walls for a minute, because the walls were by far our biggest challenge. And that's mainly because in that load bearing setting, it was very difficult to try to find a fabricator that was willing to take on that challenge and create a wall that was fully finished, right? That we're talking, AVB, insulation, girts, windows, everything is done. Finishes are on the exterior of it. But then to do that, in a load bearing world, there's not many people that were willing to look at it. We finally found a partner that was willing to do it. It took a lot of trial and error to get it there, especially when we're trying to do this in an extremely tight passive house standard, air
Hmm.
scenario, which was just another layer of difficulty on top of it. But those walls, at the end of the day, the goal was to do nothing on the exterior of the building. So you think about how much time is spent on lifts and swing staging and battling snow. We just had a blizzard here in Boston, right? All the stuff that thwarts productivity and costs a lot of money, especially in a high labor union market like we work in. The goal was to have those panels be set and done, and nobody's going on the exterior of the building at all. We weren't able to completely get there on the first building, but I'm super happy to report that on building number 2, we were able to accomplish that by tweaking our design a little bit. So now all of our primary seals are done from the interior of the building, where
Yeah.
somebody is, walking around at their leisure from the inside, protected from the weather, doing all of our seals between the panels. So again, it's, you don't know what you don't know until you physically get out there and try to do it. And unfortunately, we do work in a very risk adverse world, but taking little bites, right,
Hmm.
each
Hmm.
time, has been the way that we're going to move this ball forward. And then
Right.
once you get to a critical point and people, start to understand that there's some real value here, both in time and money, I think it's just only gonna advance even further.
Yeah, yeah. So I can't resist to draw the parallel to in clean energy. There's something called Swanson's law, Wright's law, or the law of learning by doing, right? Which says that every time you double the deployment of a technology, the little micro innovations that happen to make that deployment possible, like to make it real in the real world, is those turn into what is known as a learning rate, which is a percentage of cost decline.
Sure.
So every time solar panels are doubled deployment is doubled around the world, the cost decline is roughly 20%. And so what is awesome is that that you are setting up the conditions. It's different again because you're not doing a gajillion solar buildings. You are doing 15, but you're setting up conditions to really have some rigor with benefiting from that learning rate. Or that learning process. So what other tweaks are you looking to make between building 1 and building 2?
Sure. So another one is kind of back to the core, right? So, you think about, stacking up your core and your precast panels. You're connecting these with a ton of welding. Your CLT sits on angles that are basically welded to the side of the core that are on embeds. The first one, we spent, I don't know, hundreds of hours of guys on lifts welding, all of this stuff around the exterior of the core. The charge was, this time around, imagine that this is an 18-story building, right? If we go back and talk about code, you can now under 2021 and 2024 IBC build CLT buildings to 18 stories, right? So this is a building system that can go 18 stories tall. On 18 stories, you're not getting up there with the lift guys, right?
Right.
So how do you design this to be able to erect this core completely from the inside of the core, right? Do this in a manner where you don't have to do 50 welds from the outside, rely some more on some bolted connections, but we're going to do everything from the inside. And yeah, was it hard to pull everybody along and force that innovation? It certainly was. But I'll tell you, we got there, right? In this second building, this core will be fully erected from the inside. And I'm confident that if we find an 18-story opportunity, we can absolutely use this system now to be able to accomplish that in a much more efficient manner. I will also say too, we used steel stairs that were prefabricated in the first building. We are now in a full precast system. So this is precast stairs, landings, walls, all together that are erected in sequence. And then, one more important piece on kind of, addition by subtraction, you think about an exterior material hoist, man and material hoist, right? That goes on the outside of any high-rise building to make sure that you can get all your people and your material up into the building, right? But that hoist, at the end of the day, is just wasteful dollars. It's just temporary dollars that don't go to the value of the building itself. You build a foundation for it that you just throw away. You pay to rent it that you don't never use again. That could be hundreds of thousands of dollars that could be redirected into the actual material, tangible value of the building. So on the second building, we're stacking up our 10-story core, right, all the way up to our top of our elevator penthouse. We're going to turn that core immediately, once it's done being erected, into a weather-tight enclosure. So think about it, it's kind of its own little building that's freestanding there. And then we get our elevator contractor in there in like month 3, have him build his elevator room that's on the first floor, right? And then start building those elevators in the core while we erect the rest of the building around that core. What that then allows us to do is by the time we are done with, the second tower of erection, that turns into our man and material hoist, the actual permanent elevator.
Right.
Is what's going to service the men and materials, right? So it's, and you also save, you think about an exterior hoist where you have all these comeback units because you had to leave out pieces of the facade and all the sequence of work and all of the, of the time that's been coming back that's out of sequence that you don't want to ever do work out of sequence. We've now don't have to deal with any of that, right? We're using a permanent structure and we've just had to, change the way that we think about how you get, additional duty, again, out of the parts and pieces that you're working with, and not spending money on access and temporary conditions that we would do in a traditional construction world. So those are a few of the examples. I mean, if we kind of extrapolated this out, my goal is to get to a point where we're, kind of in a realm where we have no cut construction, right? Like I don't want there to be a saw on the job, Zach. Like that's the goal.
Right.
Is you're getting out there and you're looking at a set of instructions that's akin to IKEA, where anybody can look at point A to point B, Here's how it gets bolted together. Here's how it goes. But there's no waste or there's nothing being created on the job because it's all been very well thought out. And the simplification of what you have to do in the field to put it together has gotten to a point that's just, extraordinarily productive. So yeah, I don't know. Maybe by building 6, we'll get there. We'll see.
Right,
Yeah,
right.
yeah.
So yeah, no, that's a great vision. So a little bit about the cost. Like I know I've heard some numbers, so I'd love for you to share them with listeners. What did building cost? Building 1 cost. What do you see for building 2? How does building 2 compare to a conventional building version of building 2? And where do you see this cost headed?
Sure. So, speaking truly hard cost here, right? If, excluding all the other design, everything else, if we're talking just construction, you're going to sign your GMP for a project. We built the first building for around $585 a square foot. We could have built that building out of stick because, right, it was only a 6-story building and I probably could have done it for 5 to 6% less. And that was, an extreme challenge with our investors to kind of get over the hill of why am I paying a premium for this? Well, you're paying a premium because once we start building 8 to 10-story buildings, I'm going to save you 15 to 20%, right? Because if you can't build that out of traditional stick construction, you're back into the realm of, more, much more costly concrete, steel, etc. Right. So the second building, which now is, truly a high rise at 9 stories, we're driving that cost to just around $500 a square foot in our hard cost, right? So we're getting,
Wow.
if you think about that, compared to a more traditional high-rise structure, we're getting close to that 15, 20% mark for sure. And then, the real exciting part is, in Charlestown, I mentioned we're capped at 10 stories. But once you get to 12, 14, 16 stories, that benefit is only going to skyrocket because of your, the structure and the cost compared to what you're building just gets that much more efficient as you get taller. So we will continue to drive that. My goal is to be somewhere, in the 4s at some point. And again, this is a full union environment that is, a very old school sandbox that we play in. It's probably as heavy loaded as you can be with different terms of labor burdens, et cetera. And it is a hard ship to turn, but we are trying to push it. And then I'll go back to again, it comes down to those small bites that we're able to take with each one of these to try to advance the ball, one step at a time without extreme change that really rocks a lot of boats, right? So that's certainly a part of the magic, but you can see the cost has already started to move for sure.
Yeah. So building to 9 stories, you expect it to be $500 or so dollars per square foot, which is about 15 to 20% less than a conventional building, 9-story building built from concrete and steel, right?
Sure. Yep.
And it's also passive house. So I think that's one of the things that's pretty revolutionary about what you're up to is that it is removing the conversation about upfront cost with the assumption for extra upfront cost for a passive house building because it's baked into what you're doing. And you are figuring out all these ways to increase performance by reducing material use and reducing cost and understanding the system, how all the systems are interrelated. Do I have that right?
Absolutely. I mean, it goes back to, again, if you design a building, if you start down a path and you're not designing a passive house building, you get into a DD set of documents or, almost into CDs. And then you say, all right, now we want to try to make this thing passive house. You're going to spend a lot more time, again, kind of redesigning, looking at things. You've already costed it with contractors that have looked at this. They're not going to give you full value back on what you're asking for. You got to bake that cake with it inside of it to start. Be very, intentional through your design on how you're going to get there. And start your modeling very early. Again, I started there, but that's instrumental to this is commit to it, understand what your boundaries are, what your constraints are, and then just work with those, right? In the design realm, we like to call it, we design these buildings from the inside out. And what I mean by that is conventionally, you look at a site and you say, hey, Mr. Architect, what can we put on this site? And that architect makes you a mass of a building that kind of works to the zoning and everything that it is. And then you say, okay, here's the mass of our building, and now we're going to try to figure out how to stuff everything inside of it and make it work. We do the opposite, right? We look at all of our boundaries, our constraints that we've set for ourselves, especially on the passive house side, And then we start to build outwards, right? So what are the dimensional constraints? What are the energy constraints? What are the glazing ratio constraints? And then you start to work yourself out towards the form of the building that makes sense for the parts and pieces that you're putting it together with, right? And the simple example of this, it's not the passive house side of it, but you think about CLT, right? CLT is 8-foot wide planks. If you think about manufacturing something, you want to use the manufacturer's largest capacity of what they're pressing their CLT on with each press of that machine, right? So we get our wood from Nordic Structures, who's an awesome partner. I'll happily give them a plug here. They're saying, hey guys, you use the entire press. That's how you get more efficient cost wise. But you think about those 8-foot increments. Your building wants to be dimensionally in 8-foot increments, right? You know what I mean? You want a nice 200 foot building, right? Like not 200, 2 and 2/8, right? Like, and we don't tend to think like that enough in architecture and construction. But we've really tried to, steer that paradigm in a little bit different of a direction by really focusing on all of the different passive house manufacturing, all of the different constraints that you're looking at, especially energy wise, from the start, and then work yourself outwards to end up in a place that is still an awesome, beautiful product, but had a lot of thought put into how you put it together.
Yeah. And you've alluded to this, but we're talking about a building that is using significant or is emitting significantly less operational carbon, as well as embodied, the upfront embodied carbon because of your kit of parts.
Yeah, that's absolutely right. And these first two buildings, we built the exterior walls out of light gauge metal, right? And this was, just because that was, what we thought would work, and it did work, and it works just fine. But as you start to get taller, light gauge starts to become problematic because of some of the different loading conditions and stud packs and, punching shear through your bottom track. This was another, example of, hey, let's compare two things together. If you look at them side by side cost wise, there's no way it's going to work. But let's holistically analyze the problem and see if there's actual value here, right? So I think where I'm going with this is I think the second building in Charlestown will be the last building I build with light gauge metal stud, meaning, I want to go to a vertical CLT panel for my exterior wall. So that would be a load bearing, exterior 5-ply panel that would get married together with the 7-ply floor system. The cost of that CLT versus the metal stud is, again, 2 to 3x. You're like, this is never going to work. With the simplicity of the system downstream, right? If all of your connections become much easier. You think about, what is one of the number one thing in passive houses, get rid of all of your thermal breaks. Well, metal stud is an absolute conductive highway, right? CLT is an inherent, 5-ply CLT is like an inherent R6, right? So you're already starting with something that is insulative, and then you have a solid panel that you're then connecting all of your stuff to, where you're not trying to find studs and create additional attachment points, etc. So if you add up all of that stuff, it actually is a better performing wall that solves a lot of structural problems and becomes a even less carbon of a footprint, because you're eliminating all of the energy that goes into creating that steel, right? So now, we're going to keep the precast cores because they work great and they do a ton of duty for us, so we can go very tall with that system. But you think about the rest of it, basically coming from trees, which is amazing that you can go 18 stories with this now. And I'll also give, one more challenge. I said it before, but we are still very bad at tolerances, right? When it comes to construction, we work in inches, right? We're maybe happy if we get within a half inch or a quarter inch of what we need for clearances on stuff. If you think about any other industry, they're talking about manufacturing in microns, right?
Yeah, right.
Millimeters of clearance. That's something we need to do way better at. That is also something that CLT is excellent at, right? You're taking your entire digital theory, right, in a model that you're putting together in a digital world, and then you're putting that directly into fabrication on a giant router table, right? That's going to give you a CLT that's within an 1/8 inch over 60 feet, right? So that's another advancement where you're taking this and you're just digitally fabricating it directly with an extremely stable material that is, sustainably awesome and has a huge aesthetic value to it. So it's kind of a win-win-win. You just got to get over the initial shock of when you try to compare these costs of things, against one another. to kind of understand the downstream benefits of it and what you're
Right.
not doing. Back to the
Right.
addition of
Right.
subtraction, right?
Yeah, yeah, absolutely. And that understanding the system, I think that will really resonate with people who are listening, because I mean that's like, oh wait, the triple pane window is so expensive, but when you look at the implications on smaller, the smaller HVAC equipment necessary, and all the different kind of downstream effects, so that applying that same thinking to all of the decision making you're making in the building is really compelling. That's
Yeah, and
super cool.
I'll give one final thought on that. When it comes down to just designing your building properly for the loads, especially in the passive house
Mm-hmm.
realm, right? Like these buildings
Mm-hmm.
become so efficient.
Yeah.
A lot of engineers, are just slapping, 1 ton units here. It's kind of just like best practices. You
Mm-hmm.
got to find an engineer that's diving into this, super deep to understand what those loads actually are going to be in the super high performing envelope that you just put together.
Yeah.
There's a ton of money to be saved, in capital cost and operational cost if you find somebody that's willing to really size the project properly. And again, that's just pay attention to who you're hiring to do that sort of stuff.
Right. Right. So this has been incredible, Nick, as I knew it would be. One of the things that's super exciting about this is that you and the team are paving the way here with this new model for approaching construction. And I know that you are sharing that information very generously out into the world. Like, what are ways that this learning that you're doing can benefit the broader community? Like, do you have thoughts about that or plans
I don't know,
around
man. I guess
that?
it's doing more
Yeah,
stuff like this.
yeah,
Attending conferences,
yeah,
talks.
yeah,
As much as we can. We do truly believe that the more we learn, all boats rise as everybody learns to make it
yeah,
better. Right? We have
yeah.
certainly in the Northeast, we have a housing crisis, right, where we can't
Hmm.
produce housing fast enough at a cost point that's going to serve our community. Our goal is to try to break those barriers down to provide housing for folks. Right, the more people
Yeah,
we can share
yeah,
this with, the better that it will be for everyone.
yeah,
How best to do that? I don't know. Again, just
yeah,
keep
yeah, yeah.
talking about it. I love talking about it,
Yeah.
obviously. You can
Yeah.
tell.
Yeah.
Yeah.
Yeah. Yeah. That's awesome. Well, thank you so much, Nick. I don't know if there's anything else you want to close with or share before we close up, but this has been super great.
No, I appreciate the time. Again, I'm always happy to pick up the phone if anybody has any questions. After they hear this podcast, please look me up. Always happy to share and help everybody move it all forward. Again, we just got to get better at what we do in this industry, and I feel super super blessed to have the opportunity to try to do that, like we said, incrementally across this project, which has been awesome.
Great conversation there, Zach. Really enjoyed that. Lots in there. What stood out for you most?
I mean, I just, as you could see from the conversation, I'm just super excited about this. This is promising to deliver on the big promise of technology and innovation in buildings being able to deliver a step change in performance, in carbon reduction, and in cost reduction. So, all of us, I think, will be looking eagerly at how the numbers play out for building 2 and building 3 and building 4. But this ability to do the iteration and take advantage of the learning curve in buildings that we're accustomed to seeing in other sectors of this big transition we have to make around climate is super, super exciting. What did you think?
Yeah. I took a whole bunch of notes. There's so many things in there. I probably don't need to repeat them all, but just the hearing from a senior project manager who clearly has a bit good handle on all the technical details, but really emphasizing that point about if you commit to it early and you design from it at the beginning, you can accomplish these performance outcomes without a huge amount or any premium. And that is so significant. We say that all the time, but coming from a project manager who's delivering a project in real time, it really helps to have that coming from practice. And And the other, just at the end, he made a little interesting comment about the convincing of the investors. And I get the sense that Nick, talks about a few things that were a little bit challenging and can look back at them relatively lightly. But convincing investors is not necessarily an easy thing, convincing them to spend more money early on. And he mentioned that the first stages of this project were a much higher, or a higher cost per floor area. But that has paid dividends further down the track with the learning that they've been able to get from doing that. And and there's lots of similar stories about that learning as you go. But stepping back from that, I think the bigger thing is getting people on board right from the start, and including the investors, all your building science people. You can't, even the fabricators. None of this is going to happen if you don't have that buy-in early on. I guess that would, if there was one thing that I'd pull out from all the
Mm.
great quotes that Nick had, it would be that, just emphasizing that the importance of getting people truly on board, not just having all your contractors lined up, but people actually fully invested in the project.
Yeah, that's a great point. And it's that idea of that buy-in is actually that's kind of a microcosm of what the entire community of practice is grappling with in Massachusetts, right?
Mm,
As because they are seeing this transformation from passive house being sort of elective to being something that you just got to do. And it's so
yeah,
important that these projects are successful for the kind of durability of this policy. We're
yeah.
really excited about this progressive policy in Massachusetts with the stretch code. It needs to be successful and durable, and people, we need to be able to point to success stories. So that buy-in is critical in general. And it reminds me of an observation that Andrew Steingeiser made from RDH Building Science about what the kind of the era that they have entered in the region. And maybe I mentioned this in the interview, I don't remember, but what Andrew described was that they are in an era of optimization, and they're at a place
Yep.
where they're creating buildings with less material to use less energy, and therefore they cost less, they perform better, they reduce carbon. And it's that optimization. And RDH Building Science has been instrumental in this whole project, and in the
Yeah.
innovations they've discussed, because they were been the the enclosure consultant on the project, the PS verifier, and had a second facade design team working with the fabricator to be making these tweaks and optimizing the prefab panels and the whole kit of parts that Nick described in the interview. So really, really important role that RDH Building Science is playing. So it's just that they're at a different place in practice than
Yeah.
most other regions. I think there's some other places in the world where passive house is mandated, but it's not common in the U.S. by any means. And so it's heartening to see the kind of creativity and kind of top level of their game happening in project teams like this.
Well, I think, yeah, and Nick kind of alluded to this. That's the privilege or the opportunity that you get when you have such a large project, because I guess that allows you some tolerance on the first projects with the investors to say, hey, look, we
Hmm.
this is a big, this is a marathon, so we want to spend a bit more up front and get things right. And you don't necessarily have that bandwidth and that luxury if you just got to deliver one project and that's it to the
Right,
best budget.
right.
And I think there's a lesson in there for municipalities and urban renewal, that it's much better done at scale, because you can, aside from the geographic planning and the just better urban design, you do get some economies of scale in being able to do this and look at the big picture and see it as a learning journey. Because Nick points out that the building 6 is going to be a lot different in terms of speed and some of the systems that are developing than their very first project, going from welding to saying, okay, well, how can we bolt this on from the inside? And you mentioned RDH, that was another example of where Nick said, oh yeah, we had to search around and find someone who could do a pre-finished load-bearing wall. he kind of skipped over that process. I'm sure there were a lot of consultants involved in that, and people like facade engineers and people doing the woofy modeling and doing all of those other bits and pieces to come ultimately to that solution. It's worth us, I think, deep diving into some of these other elements of this project, because there's some amazing stuff going on. And I think the other thing I was reflecting is that a lot of this is happening here, and I'm sure in other parts of the world. Like CLT is starting to be used around the world, and so this is great that Massachusetts is sort of biting this off, but there's learning here for the world. This is
Hmm.
and computer modeling that we're doing these days, the processes, some of the materials, they're much more global in the same way that an IKEA piece of furniture is global. There's no reason why we can't have building systems that are more global, and then we all benefit from that learning rather than having to reinvent the wheel in all around in different countries.
Yeah, I could not agree more. I mean, we alluded to that a little bit at the end of the conversation, but the transparency and the willingness to just like show all the details that Nick and Andrew and
Yeah,
everyone on the team has is just, it's like that's just super powerful. Like there is
yeah,
this expensive learning process that happens with first movers, and they're reaping the rewards of that on their second project. Well, the rest of the community, the rest of this movement, if we're going to call it a movement, also gets to benefit from that. And it's where it's at. I mean, that's how we're gonna do this thing is figure out models that can be replicated and repeated over and over and over and made a little bit better every time. It's yeah, that's it's just that story of human ingenuity working through problems and making things better. It's a
mm,
very hopeful. It's a nice salve these days. I will say that it's a nice salve.
yeah, yeah. Some great pictures on the website for Stellar Bunker. I do have to the someone pointed out there's still gas-fired domestic hot water on these buildings. I assume that's still relatively standard in that part of the world, still relying on gas.
We are in a transition with hot water for sure. I mean, I think and it's also, some of these projects get design, those decisions about those systems get made years in advance. So
Mm,
I think that we're gonna see that transition.
mm,
Yeah, yeah. But yes, it is still common and is particularly with multifamily projects.
yeah,
But I think
yeah.
it's changing.
Yeah, and I guess that that some of the evolution that's happening there are systems, large buildings with a long time span, building systems that could potentially be swapped out as more
Hmm.
technologies become viable. And I guess that's just the part of the reality of certain places and the cost. We talked about the cost of electricity recently, so yeah, that'll be an interesting one to watch. But
Yeah,
aside from
right.
that, yeah, some really great learning. Yeah, any final comments from you from this one? I mean, there was so much in there.
No, I think I've gushed enough.
Yeah. Yeah, I mean, I just really appreciate Nick commenting a couple of times about the importance of getting things happening early, including the modeling, and he's starting the modeling early and in having that as much as possible define. It's almost function over form, defining, letting that define the form as much as possible, rather than just being given a near complete design and say, here, make this work. Starting with all those constraints early on, and that we know that that's the best way to do things. It's often a challenge to get into that situation where you do have the ability to inform the design from the constraints forward. So it's great that sounds like it's happened in this project and could be an inspiration for others to do that going forward. Really great stuff. Looking forward to seeing that project's in progress, because I think it's got a little way to go.
Yeah, it does. It does.
Yeah.
They're working on they're about to start building two, and there are just 13 more buildings after that.
Yeah. But they're obviously ramping up speed, so we'll keep an eye on that and hope, catch up again with Nick and also you mentioned RDH, maybe some of the other people that are involved in that project as well, because there'll be a ton of people who are involved in some way and some really, really great learning. And of course, from the wider Massachusetts that we mentioned as well, is really paving the way for other jurisdictions.
Yeah, absolutely.
Or
I should say too that we'll include a link to an article about the project by Andrew
oh
Steingeiser
yes,
that's at the Passive House Accelerator, and also Andrew presented the details around the kit of parts for the project at the Reimagine Buildings Massive Impact Conference late last year. So if you're a member of the Reimagine Buildings Collective, you can take advantage of the recording of that presentation. It's really excellent.
great. All right, we got anything to plug coming up this week, Zach?
Yeah, this week we are joined by Rockwell North America for a component spotlight as part of our Passive House Accelerator live series on Wednesdays. It's called Sound Off, Designing for Optimal Acoustic Performance with Rockwell. So we're really looking forward to that. And Rockwell's been a long time supporter and has a hand in many of the projects that we talk about on this podcast.
Awesome. All right. Well, thank you very much for bringing us that interview. We'll be back again next week on the Passive House Podcast.